Hi there, my name is Ogodino Ucheju. Hope you are having a lovely holiday. Our lesson discussion for today, or the topic I want to treat today in further maths is number system. But before we go into what number system actually means and how to apply them in mathematical computation, let's observe or look at our lesson objective for today. So our lesson objective for today is, by the end of the lesson, the student should be able to state the number system in use for computation, use the number system to solve questions. So a number system to the base p, where p is a positive integer, is a positive integer of a system consisting of the digits 0 to 9. In this system, or in this chapter rather, we examine the number system used in real life and computer. The number system we consider a decimal system, which is base 10, binary system, which is base 2, octal system, which is base 8, and hexadecimal system, which is to the base 16. Now, types of number system. We have the decimal system, the binary system, the octal system, and the hexadecimal system. In case you didn't get me the first time, decimal system is base 10, binary system is base 2, octal system is base 8, hexadecimal is base 16. Sorry for that. Now, decimal system. The decimal system is a number system to base 10, and it consists of the following digits 0 to 9. It is the most familiar number system. Example 1. Write each of the following decimal numbers using the expanded notation. Okay, if you are going to write this number in the expanded notation, what they actually want you to do is what? You recall in your, please hold on a sec. Please just hold on. Let me highlight. So, sorry for that delay. Now, if you look at this number now, 7342. You remember in your normal mathematics, even in junior secondary school, when you are taught binary system, if you want to change from, let's say, base 2, which is binary, to any other base, remember you write something like this on top of it, 0, 1, 2, 3. So that is what you will do this time around. You behave as if you have, or in your subconscious or in your imaginary way of solving it, put 0 here, 1, 2, 3. So if you put 0 here, and everything mind is to base 10. So if you start from the first part, 7 times 10 raised to the power 3, plus 3 times 10 raised to the power 2, plus 4 times 10 raised to the power 1, plus 2 times 10 raised to the power 0. The same goes for the next one, digit 4086. We have 0, 1, 2, 3. For this other one here now, 0, 1, 2, 3, 4. That's why the highest power here is what? 4, and so on and so forth. That is, I think that one is explanatory enough. Now, example 2, write each of the following numbers. Sorry, I'll take it again. Write each of the following numbers in base 10 using the expanded notation. The only difference between this example 1 and example 2 is, in example 1, there was no decimal place, like 0.86 now was not present in example 1. But in this example 2, so what do we do now? In this very particular part, you do what I've taught you before, just 0, 1, 2. Then this part, you say, this one should give us what? -1, -2, and so on and so forth. So this one 0, on top of this 6, you have imaginary 0, 1. On top of this other one, you have, begin here, -1, -2, and so on, depending on the number of decimal places. For this 9 now, it should be -1, -2, -3. But this one is 0 and 1, all in base 10. I hope that one is clear enough. Okay, let's go to the next slide. Binary system. The binary system is a system of number which has base 2 as its base. The digits in base 2 are 0 and 1. Addition in base 2. So in your junior secondary school or your junior secondary class, you were taught that 1011 plus 1101. If you add 1 plus 1, we have 10. So you write 0, you take 1. That one you've taken to this upper part. 1 plus 1 plus 0 will give you 10, not 10, because you're not dealing with base 2. So you call it 10. So you write 0, carry 1. 1 plus 1, 10, carry 1. Now if you have 1 plus 1, that's 10 plus 1, 1. You write the 1, and so on and so forth. So we are not going to deal or treat this binary addition and subtraction very much, because You have done that in junior secondary school and also in other part of mathematics. But what I will mostly concentrate on, let's go to the next slide, please. Sorry, pardon me for doing this. So what we are going to treat now is the next slide. And that next slide is this now. So you know how to subtract normally before. If you want to subtract, let's say this first one, subtract 8421 minus 3842. The thing we do here is just say 1 minus 2. It can't go. You borrow from 2. Hope this my what's it called? It's not blocking your view. Okay, let me put it aside now. Let's move it away. Okay, now 1 minus 2 cannot go. You borrow 1 from 2, and that will give us what? 11. 11 minus 2, 9. Then at this particular point, okay, I'll bring back this thing. At this particular point, so at this particular point, you say 11 minus 4. You get your what? Your 7, because you borrowed from it already before. You borrowed 1 from here. So this place becomes straight. This place remains straight. Now, if you subtract, and so on and so forth, you know how to subtract. I guess all of you watching this video know how to do simple subtraction. So let's go to our main focus for today, which is complement. Okay, let's talk about the ninth complement. The ninth complement of a number in base 10 is a number obtained by subtracting each digit of the number from 9. The 10th complement is a number obtained by adding 1 to the 9th complement. So if you are going to use this particular complement method to subtract, let's see how to do that. Let's go to the next slide. Now, evaluate each of the following using the 10th complement of the subtrahend. Now, in this particular method of subtraction, the first digit above is called the what? Minor end. The lower digits are called the what? Subtrahend. Subtrahend. Now, when you want to subtract, don't look at the minor end. The ninth complement or 10th complement you are going to look for is actually based on the what? Subtrahend and not the minor end. So the ninth complement is simple. Each digit, okay, if you want to understand, if you don't know what digit means, 7 is a digit, 5, 2, 7. So we have 4 digits here. So let's subtract the first digit, 7 from 9. 9 minus 7 is 2, right? Or, sorry, we are making a mistake now. Let's go back to the subtrahend. This is the 10th complement already. Let me go back to the subtrahend. So let's go back to this now. We are subtracting 2, 4, 7, 3 from 4, 8, 6, 1. So this 2, 4, 7, 3 is what we call the what? The subtrahend. And why this one is the what? Minor end. Now, this subtrahend, 9 minus 3 will give you 6. Put that one side. 9 minus 7 will give you 2. 9 minus 4 will give you 5. Then 9 minus 2 will give you what? 7. So remember we got 7, 5, 2, 6. That is the 9 complement. So we don't need the 9 complement. What we need is the 10 complement. So once you get the 9 complement, add 1 to the 9 complement. So let's go over the 9th complement again. 9 minus 3, 6. This place we have 7 is supposed to be 6 if you are talking of the 9 complement. Then 9 minus 7, 2. That's why you have this 2 here. 9 minus 4, you have 5. 9 minus 2, you have what? 7. So 9, 5, 2, 6 is the 9th complement. But when you add 1, you have 9, 5, 2, 7. So when you have that particular 10th complement, you come and add that 10th complement to the what? Minor end. So 4, 8, 6, 1 is the minor end. 7, 5, 2, 7 is the what? Is the 10th complement. So add normally 7 plus 1, 8, 6 plus 2, 8, 8 plus 5, 13, carry 1, 7 plus 4, 11 plus 1, 12. Now, when you've done this, remove the first digit. If you remove the first digit, remove it and throw it away. Then your answer should be 2388, which is the same thing as if you have subtracted with the normal method you know before without using the 10th complement. This is what you still get. So this is another method of what? Of subtraction using the 10th complement. So this is basically what some of your computer does, especially the first generation computer. If you give them subtraction to do, they do this in words, in complements and the rest of them. So let's go over the second example. Then I believe after the second example, you should know what to do now. So in this question, 4861 minus 2473, Our minor end is 4, 8, or sorry, this is our next question. I beg your pardon. 7, 8, 5, 6 is our minor end. 3, 9, 4, 7 is our what? Subtra end. So if you want to get a nice complement, okay, 9 minus 7, 2, but this is 10's complement already, so that's why you have 3. So in your own imagination, 9 minus 7, put 2 one side, 9 minus 4, 5, 9 minus 9 is 0, 9 minus 3 is 6. So add that your answer 6052 plus 1, you get 6053. Go over here, add your 10's complement to your what? To your minor end. And when you add, you have 13909. Remove the first digit and your answer is 3909. If you subtract with the normal method before, that's the 7856 minus 3947, this is what you get. So using the word times complement. I hope that is clear enough. So let's go over to the next slide. Now let's talk about complement in base 2. The ones complement of a binary number is obtained by changing each 0 into 1 and 1 into 0. The 2's complement of a binary number is therefore the ones complement of the binary number plus 1. So what do we mean? Let's go over to an example for more clarity. Example 3, evaluate each of the following in base 2 using the 2's complement. A, 1, 1, 0, 1 minus 1, 1, 0. So if you are going to use the complement method, our minor end is 1, 1, 0, 1. Our subtrahend end is 1, 1, 0. So if you want to get the ones complement, just change 0 to 1. Change 1 to 0. Change 1 to 0. Then if you are going to get the 2's complement, add plus 1 to it. 1 plus 1 will give us 1, 0. You take that 1, 0 to the other side, becomes 1 and 0, 1, 0. So this one, 0, 1, 0 is our 2's complement. Adding your 2's complement to your minor end will give you 1, 1, 1, 1. Then remove the initial one, the first digit there from this other part. Then your answer will be 1, 1, 1, and so on and so forth. So with this, we have come to the end of this class. So with this, we have come to the end of this class, and I hope what I've given you as an explanation will help you to understand the notes I've uploaded, that's uploaded earlier to you guys. Please make sure you stay safe, read your book, make sure you always do your assignment given to you by myself and other teachers of this great school, God First International College. Until we meet again, I love you guys. Bye.